Reaction of chloride is water. Okay, here we go. Run through left to right, right? All of them. Okay, ladies and gentlemen, ionic chlorides. The ionic only 2. So what is the difference? Is there. All right, so here we go. Make it big one at a time, never mind. Now, ionic chloride, once again, they will always do what? They will always dissolve in water through ion dipole interactions. Where are we? We are in bonding, we're in energetics. Basic fundamentals. Why the ion dipole interaction? Simply because the dipole comes from the water, which is polar, and the ions come from your ions. And eventually they form your hydrated ions. So take a look at sodium chloride. First few marks. Sodium chloride has very low charge density. Okay, I'm running out of color, so I uncolor everything. So here we go. All right, sodium and chloride ions has very low charge density. So once again, what is charge density? Charge density is equals to charge over size. So let's just compare sodium ion versus the rest of the cation. All right, the charge is quite small, 1 plus. The size is quite big compared to the other ions along period 3. So therefore, this is small. Done. Bonding 101. Energetics 101, right? So because of its low charge density, all right, the sodium chloride itself, this salt, will therefore not what? Will not hydrolyze in water. What they do is they only dissolve in water to form a neutral solution of pH equals to 7. The equation that you want is this equation. Some people go and do this kind of mistake. Some weird acid-base reaction occurring here. Okay, they do some weird reaction mechanism, right? Once again, sodium chloride doesn't do this. They only dissolve in water to form pH 7. They don't hydrolyze. Now, what is this known as? Right? So if you take a look, what happened? Sodium chloride by right has what? By right has strong electrostatic forces, right? Ionic bonding. And the water come in. Water is here. Okay, whichever, one here, one there. So what does water do? Water is a polar molecule. It then forms this tube. Right, here's delta minus, by the way. Running out of colors. Let me just use spin. Delta minus, delta plus. This delta minus, this delta plus. Oh, I draw wrong way. Okay. So I just draw one. All right. Draw 2. Just a moment. Okay, what is this? Opposite charge always attract. This is what we call your ion dipole interaction, which is very, very strong. Stronger than electrostatic force of attraction, and therefore it overcomes it. Okay, wrong way. Overcome this one, the electrostatic force of attraction. And if you look at it, this is what we call a hydrated ion. All this was since secondary 3. Yeah, I zoom. Very sensitive. So, ladies and gentlemen, hydrated ion, sodium, hydrated ion, chloride. Okay, so what is happening over here? What is this reaction called? This is called hydration, which forms your hydrated ion. Next, magnesium chloride. Our pH is not 7, it's 6.5 right now. Why? Magnesium chloride has, the Mg2 plus has a higher charge density than sodium plus. So MgCl2, right, will do what? Okay, it will dissolve in water, and the hydrated ion will then undergo something else. It's called slight hydrolysis, which therefore form the slightly acidic solution of pH equals 6.5. What really happened here, if you look at it, is that the same thing happened like sodium chloride here. There are 2 steps. Each of them has a name. Once you get this, you're okay. The problem is in school, they read out this and then they never explain. And therefore, you also memorize it without understanding. It's hydration. Take a look. It makes sense. Magnesium chloride, put into water, you form this. So what happened is the same thing. Mg2 plus, there are Cl minus. Obviously, this side got another Cl minus, which I don't want to care. And then the key thing is there are what? There are water. How many? Not one, but 6 water molecule. They will do ion dipole interaction with it. So it do how many times? It do 6 times. Okay. Am I okay? That's it. And 6 water molecules, all right, surround it. Once again, this blue color is your ion dipole interaction. And therefore, you break the electrostatic force of attraction. Now, chloride, why don't we also put 6 water over there, right? Nothing wrong, you can put, but the thing is the chloride there doesn't affect our pH, so we don't show it. Understand what I'm doing? Make sense? Right? All we want to show is why the pH is 6.5. The chloride there won't affect the pH, right? So we don't show. So this is your hydration equation, 1 mark in exam. Okay, single arrow. Then you have a second step. What's the second step? The second step is here. The second step is known as hydrolysis. Hydrolysis comes from the bio term, lysis means break, hydro means water is involved. That's it. So if you look at it, what really happened is this. Right? So your current hydrated ion, which is here, okay, your current ion is here, right? Oh, there are 6 of them. I just draw 3. You don't mind, huh? Okay. Oh, there are total 6. Then what happened is there is a water molecule that come here. Hello, I am water. This is the one. You know that hydrated ion over here, what is it working as? This ion is basically this ion. Make sense? It's acid-base. This acts as an acid. This acts as a base. Okay? Now, ladies and gentlemen, this is what happened. All right? There's a lone pair here. Make sense? Take a look at the reaction mechanism. See what I see? Done. In brown. Okay? This, slowly, is actually diesel. Make sense? And this, a bit overlaid on my H3O plus, is this. So once again, there are 2 reactions occurring and that cause it to have a pH equals 6.5. All your ionic salts will get hydrated based on strong ion dipole interaction with nearby water molecules. After which, the hydrated ions, the one in pink, will then undergo hydrolysis with an adjacent, a nearby water molecule with acid-base reaction, where it produces H3O plus. And your pH is 6.5. Why isn't it higher but just 6.5? Simply because, all right, it's a reversible reaction. So it might reverse back. So the H plus that come out won't be a lot. So you get only a slightly acidic solution. Now, why once again is only like that? Why only slight hydrolysis? Why only slight? Why reversible? Simply because magnesium, yes, it has a higher charge density, but it's still not too high compared to the next one. So it's still not very high. So the polarizing power by the Mg2 plus is not very strong. Oh, so the whole idea is the Mg2 plus keep pulling this bond. Can you see now? Pull until that bond break. Am I okay? Oh, it distorts the bond here. Can you see now? Then the bond in the water that's attached to it break. Yes, then it's transferred to the adjacent orange colored water molecule. Okay? Hydration, hydrolysis. Let's go to the next one. Covalent chloride. Now, we all know this covalent, right? So AlCl3, we draw them out as covalent, blah, blah, blah. They all undergo what? They all undergo hydrolysis to produce acidic solutions also. But how did they do that? So once again, AlCl3, we usually differentiate it from MgCl2. We don't say slight, we say appreciable. Appreciable, dictionary say a lot more, okay? A lot more hydrolysis. Now, why? Versus who? Versus Mg2+. Just now that one, right? Each ion has higher charge density. So these are the technical answer. Able to draw electron to itself from the O atom in the hydrated ion more. Remember the water? So it can further polarize the OH bond in the water. Let me write this down. In the H2O molecules, right? That's attached to it through ion dipole interaction. Right? In case you don't know which water. So now it's easy for the H plus to say goodbye. To where? To just now the adjacent water molecule that's floating around. And to form what? To form, running of colors, the H3O plus. And therefore, it's acidic and a lot more acidic. Okay? Because that bond is weakened by a lot more, by a higher charge density Al3 plus. Okay? Okay, so what happened? Take a look again. This is the beauty, right? Yeah, it will undergo first hydration. AlCl3 once again will become AlH2OCl3. So it's exactly like MgCl2 there, right? Follow me closely, drink water, everyone. Important now, this one. Aluminium chloride. Then move it up, because there's things to play here. Ready? Okay, so once again, what we have. Okay, the story is it undergo hydration. And then it undergo hydrolysis. You look at the equation and everything looks similar to the one we just discussed. So all in all, if I use a color to represent, say red, say we have AlCl3. Okay, everyone? AlCl3 at room temperature is a solid. If I put into water, I run through link to bonding, everything in ready. It will dissolve and it becomes aluminium chloride. Now, a lot of people, since again it's J1, cannot accept, which I'm trying very hard to convince you all, is that aluminum chloride is covalent, but it has ionic character. When you put in water, they will dissociate. Okay, so that part sounds very weird. Simple molecular structure, how come can dissociate? Are you with me? Can dissociate to what? To this. Okay, so this is once again J1 issue. So once again, the weird part is, isn't this simple molecular structure? But how come it can dissociate here? Right? So this is dissociation, right? How can dissociate? Can. Why? Because something you learned last time also can dissociate. What? Remember this guy? Who is this guy? Yeah. HCl. Yeah, cannot draw properly. Remember HCl not? Yeah, this one should be bigger. The other side. Make sense? Hydrogen chloride gas. My friend, also same thing one. I show you, I put water, it become hydrochloric acid. And my friend, isn't it a strong acid by dissociating? Why not? Make sense? Yes? Yeah, be very clear. Don't let things conflict yourself. Yes? So I just use HCl to just discuss. Why not? Keep it simple. Okay, so I just want to use it to prove that, yeah, even it's a simple molecular structure in a physical property. Now we go to the chemical reaction. It can ionize, it can dissociate. Okay, so here we go. Now, this Al3 plus is actually what? Careful, this Al3 plus is actually, color come out already, this one that we have been writing above. And this is where it brings us very, very nicely to transition metal. If you are struggling to transition metal with all the equation, it's because this is the part nobody explained to you, or they explain you were dreaming. This is this. They are the same thing. You need to acknowledge that. Why like that, you ask me? Very simple. Because remember chemistry, there are three sections, three genres: physical, organic, inorganic. I'm trained in two of them. The other one, I purposely don't train in it. I didn't specialize in it because I hate it. The inorganic, which is here. So basically, ladies and gentlemen, this is how a physical chemist, a chemist that's trained in physical chemistry, will present aluminium 3 plus ion. This is how inorganic chemists present them. The different genre of chemistry, or the chemists don't like each other one, but their connection, yeah, is a fact. So this is a lower Al3 plus, which looks like this, and it will what? It will react with the adjacent H plus ion, sorry, H2O, and give up. So you left with what? You left with this. Okay, and all in all, most important is because of this, yeah, it's acidic. Okay, so that part shows why aluminium chloride is acidic in nature with pH equal to 3. This equation and this equation. Okay. Now, then we got to apply further. Ready? That part is the boring one. The interesting one is here. And you're going to ask you. Okay, these are all the outlier, but it won't be too difficult, right? So once again, follow me closely. When limited amount of water is used. So basically, this is when you have excess water. So this section is where AlCl3 is added into excess water. This is when you have limited water. You don't add a lot of water, you just add a few drops, that's it. Then you will see something different. What? You will see a white solid and a white film, whatever color it is. Why? Once again, is because your AlCl3, all right, let's say they are red in color, all right, react with your water, and you form white precipitate. Now, I have two equations there. I can check your school notes. Different school use different ones. They are the same in a way. That's the pain in inorganic chemistry. That's why I don't like it. There's alternative answer one. Everyone okay? In physical chem, minus calculation. Physical organic don't have alternative answer. It's fixed. All right. So aluminum oxide, aluminum hydroxide. So I might want to put M here. Okay. Outlier. Okay. The fun is here. Ready, ladies and gentlemen? If they want to test you, I think they will test you here. The bigger question: what happens when bases like sodium hydroxide as well as sodium carbonate are added to Al3 plus? Okay, slowly. So aluminum chloride, which is had the aluminum hydrated ion, which we know how it looks like. If we add bases like this, or we add carbonate like this, soluble carbonate, all right, what would we see when you add them in small amount and in excess? As you can see, lots of marks, right? Which one will come out, I don't know, or is it all? Follow me closely. Where upon addition of small amount of base like sodium hydroxide to a solution with Al3 plus, you will eventually get a white precipitate of hydrated aluminum hydroxide, which is this, is formed. Where is actually here. Slow and steady. Once again, if I add sodium hydroxide, small amount, to aluminum chloride solution. The aluminum chloride solution, for example, so AlCl3 solution. The question will tell you this one, are you with me? They always give you a compound, a salt, right? So you add to this, you add a bit of sodium hydroxide to it. What do you see? Now, this immediately, you start with this. Because I have shown you this inside there basically dissociated to give this ion. And this ion is basically this ion. Everyone okay? Make sense, everyone? You must know where to start. Make sense? Now, why is this? Okay, I jumped the gun a bit. This is actually this. Agree? Make sense? But remember, it is a solution. So your Al3 plus will not exist like this. Are you with me? It will instead, let me use a different color again. It will exist like this. Eventually, it will transform itself to this. I think it's 5, then there's the OH, then bracket, I think this 2 plus, which is therefore this one. Oh, so why the blue color ions become the red? Because of the adjacent water. There's a lot of water molecules in the solution one. Make sense? All right, and we already say it's acidic. Why is it acidic? Because it has given out the H plus to form H3O plus, i.e. this is what you have in the aluminum chloride solution. Understand what I'm saying? Okay, so if you look at this, what is this? This is currently like this. Al, and then T, right? Can I just draw a line at least? Okay, then I draw T, 4. Right? Got 6 T, right? 6 point charges. Keep remembering 6 point charges, you'll be fine. So all these are water molecules. Can I stop drawing? I'm very tired already. Then I draw for you. All right. Currently this is what? This is the OH. Make sense? Correct? Right? So it looks something like this, right? It's the OH. This is the red color that we have. So now you put in a pink. See what I see? The pink is here. The pink has lone pair again. Then reaction mechanism occur again. Can see now, everyone? Consider done. And then you form this green. This is this. Can see, everyone? Show you where's the water. The water is here. So right now, that red, the big thing there, all right, the aluminum got how many water? The green color here, right? Right now, it's the green color here, right? You got how many H2O? Still got 4. It got still 4 more acidic proton. If you Google, that's what we say in Wikipedia. That's the meaning. The water there are all acidic proton. Are you with me? Because I can give them away. So where is it? You'll carry on and give out 1 more H plus from the water. Right? The second more OH come here and it become this. And it will stop. Why it will stop? Simply because it has formed a precipitate. Why is it a precipitate? Because it got 0 charge. Please take note, everyone. Anything that has 0 charge, all right, in terms of this kind of completed ions, they are always precipitate. In transition metal, we play the same thing. Anything that has a charge, they are always soluble in water. Take a look, they are always aqueous. Okay, so happy, Ria? So we carry on. Now, actually, do you realize what is this? Do you realize this whole section here is your QA test for aluminium 3 plus using sodium hydroxide, since Sec 3, Sec 4 and J1. So in Sec 3, Sec 4 and J1, they cannot test you. Don't you agree? Me now J2, they have to test you. That's why I said the heat rate is damn freaking high for the aluminium. All right, so once again, if I add excess, yay, excess added. So I got a lot more lah. So just now the white precipitate over here, right? Still got acidic proton. How many? 3 more, correct? It has a 3 more. So go 1 more round. Then they form what? Iron dipole again. So they dissolve. Consider that. This one keep coming also, the sodium carbonate, right? So once again, if you think you want to memorize. I don't memorize it because it's very easy. Once again, aluminum chloride, how it look like? Aluminum chloride is acidic. Acidic means this is inside the solution. Everyone okay? All right, this is in the solution. So when I add sodium carbonate, so I add a carbonate ion inside, what is this? If you take a look, this has acidic hydrogen or proton. This is the acid. And this is carbonate. To me, very easy. Because my Sec 3 chem teacher say acid carbonate give you a salt, give you water, and give you carbon dioxide. Done. Acid carbonate reaction. Okay? All right. So if you want, just remember that you need to get to the white precipitate. And you see effervescence. Once again, why? Because of carbon dioxide. Once again, if you want to memorize this, please do so. Nothing wrong. SiCl4. Right? These are the other 2 covalent chlorides. They all undergo these 2, right? Complete hydrolysis, all right, in water, produce acidic solution, pH very strong, 1 to 2, right? pH very low, I mean, very strong acid. Why is it? Because of this that's produced. Take a look, HCl. Because hydrochloric acid is being produced. We should further dissociate. Right? To give you a large concentration H plus ion. Blah, blah, blah. So once again, you need to know these equations. So different school give different ones. Some school give two like me. We play safe. But they all look very similar, right? So either one is fine. Same thing for PCl5. All right, you react with water for the same reason. So the reason is same, quite easy. Once I show you one, the other one you can write it. Okay, and he has his own equation, which is here. Okay, we put in the water, it react and give you this. Once again, this will cause it to be a strong acid. But there's a small outlier here. Be very careful. Okay, now this equation is we give it when we say we add in excess water. Oh, so you add, there's a lot of water. Okay, this is what you form. But if the question asks you for limited amount of water, oh, so this is for excess, huh? This is the equation that I'm going to write. Basically, that's what I want to say. We'll start. The blue color equation comes in because of a two-step reaction. PCl3, as you can see here, when you react with more water, you then form this side. Again, if there's excess water, then you carry on to the second step. If you do, if you cancel them off, I think it makes sense. This and this cancel off, and yeah, you join them up. You'll get your blue color equation in excess. Oh, so all in all, I want to say is what? I'll say if the question very clearly, so look for the keyword. They say excess water, all right, give it this. But they very explicitly say in a very limited amount of water. There must be written why they say limited amount, right? So you cannot use this equation. You have to give this equation. Okay. All the details. Okay, all right, it's all about details over here. If not, I think the rest, nothing much. Because of HCl, that's why fumes of HCl are formed in moist air, right? Once again, all right, moist air means have a limited amount of water. That's why you see what? You see white fumes of HCl. Okay, and that's the reason why all this in the lab, they are kept in they are stored in well-kept bottles. Right? If not, they will fume and then they will kind of have some white deposits over there. Okay, that's the reason why we kept it. All right. So all in all, the trend itself, after you look at it across the period, the nature of chloride changes from ionic to covalent. Some trend, the chlorides also become more acidic. So all these are your favorite MCQ bullet points. Get it considered out. Nothing much.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.